That's why easily attraction each other. So cation attract anion towards itself. Second point. At the same time, the anion also having nucleus. This nucleus has positive charge. That's why while cation attract to the anion, same time cation repel means repulsions, repel by nucleus of anion. Cation repel by nucleus of the anion. Okay, due to these two factors together, finally anion elongated towards the cation. Anion elongated towards the cation. That means like that curve. Elongated towards the cation. This is called polarization. This is called polarization. Okay. Here we have to learn terms also. What is polarizing power? What is polarizing power? Polarizing power means the cation able to attract to the anion. The cation able to attract to the anion. Okay, cation able to attract to the anion called polarizing power. Next, polarizability. Polarizability means the able to anion attracted by the cation. Anion attracted by the cation. Anion attracted by the cation. So polarizing power we have used in terms of polarizing power we have to use in terms of cation. Polarizability we have to use in terms of anion. Okay. Now polarization costs to the sharing of electrons between the atom in ionic compound. Polarization very important point, very important. Polarization costs to the sharing of electrons between the atoms in ionic compound. Costs to sharing of electrons between the atoms in ionic compounds. When the electron sharing between the atoms, ionic bond acquires covalent nature. Very important point. Ionic bond acquires covalent nature. Ionic bond acquires covalent nature. So polarization means nothing but ionic bond acquires covalent nature. That means covalent character in ionic bond. Logic find out about covalent character in ionic compounds. How does come? While polarization going on, so ionic compound means NaCl, Na cation, chlorine negative ion. So between cation and anion polarization takes place. At the time sharing of electrons takes place between the atoms, it leads to ionic bond acquires covalent character. That's why polarization means nothing but covalent character in ionic bond. Important one. Polarization means covalent character in ionic bond. Okay, covalent character in ionic bond. This is explained by Fajans. That's why it is called Fajans rule also. Fajans polarization rule. Okay. Now, what is Fajans rule? What are the factors affect you? Right. First one, polarization inversely proportional to size of the cation. Okay, because polarization means covalent nature in ionic compound. So in ionic compound, for example NaCl, MgCl, AlCl3, chloride ion is the common. So anion, small size cation means easily attracted by the cation. Anion easily attracted by the cation. So polarization increases. Means covalent character increases in ionic bond. Okay, that's why here NaCl, fluorine common, MgCl2, AlCl3, silicon tetrachloride. So here sodium to magnesium, magnesium to aluminum, aluminum to silicon, size of the cation decreases. That's why polarization also decreases. Polarization increases. Okay, what is the reason? Sodium to silicon, atomic size decreases. Correct? Atomic size decreases. That's why polarization increases. Polarization increases means covalent character also increases. Covalent character increases means slowly ionic character decreases. Ionic nature decreases. Okay, simple one. Polarization inversely proportional to size of the cation. Sodium to silicon, size decreases. That's why polarization increases. Means covalent character increases, ionic character decreases. This is the first factor. So here you should remember about polarization directly proportional to covalent character, inversely proportional to ionic nature. Okay, this point you should remember. Directly proportional to covalent nature, inversely proportional to ionic nature. Next one, second factor, polarization. Directly proportional to size of anion. Before, polarization inversely proportional to size of cation. Now polarization directly proportional to size of anion, because anion large size means easily attract towards the cation. That's why, for example, NaF, NaCl, NaBr, NaI. Fluorine to iodine, anion size increases. Anion size increases. Anion size increases means polarization increases. Polarization increases. Polarization increases means covalent character, covalent nature increases. Covalent nature increases means automatically ionic bond decreases. Ionic bond decreases. That's why polarization inversely proportional to size of the anion. Okay, this is the next point. Next, third one. Polarization directly proportional to both charge of cation and anion. Charge of cation and anion. This is the third factor. For example, Kc directly proportional to cation. Polarization directly proportional to cation, for example. Okay, here NaCl, MgCl2, AlCl3, SiCl4. Here +1, here +2, here +3, here +4. Charge increases. Charge, greater charge increases. Charge increases means polarization directly proportional to cation. Charge increases means automatically polarization increases. Polarization increases. Why? Covalent nature increases. Covalent nature increases. Ionic nature decreases. Ionic nature decreases. So polarization directly proportional to charge of the cation. Second one, same directly proportional to charge of the anion also. So polarization B, polarization directly proportional to charge of the anion. Charge of the anion. Okay, for example, aluminium nitrate, next aluminium oxide, next aluminium chloride, Aluminium nitride, nitrogen charge -3. Here oxygen charge -2. Here chlorine charge -1. That means charge left, right to left increases. Okay, like that charge increases. Right to left increases. Charge right to left increases. So right to left polarization and covalent character also increases. Covalent character increases. Then left to right ionic nature increases. Left to right ionic nature increases. This is the polarization directly proportional to charge of cation and anion. To simply remember, polarization directly proportional to magnitude of charge. Polarization directly proportional to magnitude of charge. Next, last one. Polarization configuration. Polarization more in pseudo inert configuration than octet configuration. Pseudo inert configuration means 8 electrons in outer shell. Octet configuration means pseudo inert configuration means 18 electrons in outer shell. So octet configuration means 8 electrons in outer shell. That's why very important point number. Again listen, polarization more in pseudo inert configuration than octet configuration. Pseudo inert configuration means 18 electrons in outer shell. Octet configuration means 8 electrons in outer shell. That's why polarization more in pseudo inert configuration. Pseudo inert configuration. Okay, greater octet configuration. Octet configuration. So pseudo inert configuration means 18 electrons in outermost shell. 18 electrons in outermost shell. Next, octet configuration means 8 electrons in outermost shell. 8 electrons in outermost shell. So what is the reason why pseudo inert configuration more polarization than octet configuration means polarization required more electron ready to attraction. So here 18 electrons availability. Here only 8 electrons availability. That's why in pseudo inert configuration more number of electrons available to polarization. That's why pseudo inert configuration more polarization than octet configuration. Example, this is CuCl. Here example NaCl. That's why CuCl more polarization than NaCl. CuCl more polarization than NaCl. Okay. Right. Next one, small one, ionic potential. Ionic potential. Ionic potential means pi. This is also explain about the polarization or covalent nature. Ionic potential, this is pi, pi. Okay, ionic potential also indicate the covalent nature in ionic compounds. So pi directly proportional to covalent nature. Okay, inversely proportional to ionic nature. Inversely proportional to ionic nature. So this is ionic potential. This small topic, it represents by pi. So pi directly proportional to covalent nature, inversely proportional to ionic nature. Okay, that means this ionic potential also refers to the covalent nature in ionic compound. Ionic potential more means covalent nature also more. So ionic potential inversely proportional to ionic nature. Next, this pi directly proportional to charge. Directly proportional to charge, inversely proportional to size of the cation. Inversely proportional to size of the cation. Same polarization nature. Same polarization nature. Okay. Now finally conclusion. According to Fajat's rule, polarization or pi directly proportional to covalent nature, inversely proportional to ionic nature. Ionic nature. Okay. Next one, small concept. Polarization or pi, ionic potential pi, inversely proportional to melting point. Inversely proportional to melting point. What is the reason? Melting point. Why melting point inversely proportional to polarization? Melting point directly proportional to ionic bond. Inversely directly proportional to ionic bond. This is about the polarization and ionic potential, their relations. Okay. Then next one, formal charge. Okay. So your NEET level one formula given for formal charge. Formal charge equal to number of valency electrons in atom minus number of non-bonded electrons. Non-bonding electron means those electrons not involved in bond formation. Non-bonded electron means those electrons not involved in bond formation. Minus, here another minus, okay, number of bonded minus 1 by 2. Number of bonded electrons. So here formal charge formula very important. Very important formula. Formal charge equal to number of valency electrons in atom minus number of non-bonded electrons minus 1 by 2 number of bonded electrons. 1 by 2 number of bonded electrons. This is about the formal charge. Okay. Again, formal charge equal to number of valence electrons in atom minus number of non-bonded electron means those electrons not involving in bond formation. Lone pair electrons. Non-bonded electrons means lone pair electrons minus 1 by 2 number of bond electrons. Those electrons involves the bond formation. So this is the formal charge formula. Okay. For suppose we have to take one example. Okay. N2O structure we taking. Right. This is the N2O structure. Now this is first nitrogen atom, this is second nitrogen atom, this is oxygen atom. Formal charge for nitrogen 1. Here N1 means nitrogen 1 atom. Formal charge for nitrogen 1. Right. How many valency electrons in nitrogen? 5. So what is formal charge formula? Number of valency electrons in atom. Nitrogen valence electrons 5 minus number of non-bonded electrons. Here 2 electron. Non-bonded means so this lone pair electrons. These are lone pair or non-bonded electrons. Non-bonded electrons. Here 2 minus 1 by 2. How many bonds formation by this nitrogen? 3 bonds. Each bond 2 electron. Nitrogen formed 3 bonds. One bond equal 3. One bond equal 2 electrons. 3 bonds means 3 into 2 6. 1 by 2 into 6. That means here 5 minus here how much come mama? Minus 3. So 2 minus 3. 5 minus 2 minus 3 equal to how much come? 0. Equal to 0. Next one, formal charge for N2. Formal charge for N2. Here, say number of valence electrons on nitrogen atom. 5 minus here 0. Bonded electrons, non-bonded electrons on nitrogen atom is 0. Okay now 0 minus 1 by 2 into how many bonded electrons sharing amma? 3 this side 1. 4 into 8. So here equal to 1. Formal charge of second nitrogen. N2 means second nitrogen atom amma. Don't be N2. This is second nitrogen atom. Second nitrogen atom. This is first nitrogen atom. Next, formal charge for oxygen atom. Formal charge for oxygen atom. How many valence electrons in oxygen? We know it. 6 minus. Non-bonded electrons 1, 2, 3. 6 only. 6 minus 6 minus 1 by 2 into 2. Bonded 1 bond only oxygen connecting now. So that's a bonding electron. 1 bond equal to electron 2. That means equal to minus 1. So formal charge for oxygen atom minus 1. Like that we have to find out. Formal charge equal to number of valence electron in atom minus number of non-bonded electrons minus 1 by 2 into number of bonded electrons. Next, another example we have to discuss. You understand easily. HNO3. Okay, discuss about the HNO3. Nitrogen, oxygen, hydrogen, double bond O. Okay, here 2, 4, 6. Here 2, 4. Here 2, 4. Right. Here hydrogen. Right. On nitrogen plus charge. Nitrogen plus charge. Now see, first this is oxygen 1, this is oxygen 2, this is oxygen 3, this is nitrogen, this is hydrogen. Right, one by one. Formal charge for first nitrogen we have to find out. Nitrogen. Formal charge for nitrogen. Okay now. How many valence electrons in nitrogen? 5. 5 minus. Non-bonded electrons 0 minus 1 by 2 into 8. 4 bonds now. 8 equal to 1. 1 is answer. Next, formal charge for hydrogen atom. Formal charge for hydrogen. Here hydrogen. How many valence electrons in hydrogen? Only 1. 1 minus non-bonding electrons 0. Bonding electrons 2. 1 bond connecting, 1 bond equal to electron. So 1 minus 1 equal to 0. Next, formal charge for first oxygen. Formal charge for first oxygen. Just be assuming first oxygen. This is how many valence electron each oxygen? 6. Minus bonding electron, non-bonding electrons 4. Minus 1 by 2 into bonding electrons 2 bonds means 4. Okay, equal to 4 minus 2. Here minus 6, 6, 0, 0. Next, formal charge for second oxygen. Formal charge for second oxygen. Okay, number of valence electrons 6 minus, non-bonding electrons 6, minus 1 by 2 into bonding electrons 2. So that means here minus 1 come, minus 1. Next, formal charge for third oxygen. Otherwise I write here. Formal charge for third oxygen. Formal charge for third oxygen. Third oxygen. This is third oxygen. Na? First oxygen completed, second one completed, third oxygen. 6 minus non-bonded electrons 4 minus 1 by 2 into 2. That means plus 1. So like that you have to find out formal charges. Simple one. So exam sometimes structure given, sometimes not given. If structure given means easily find out. If not given also, second inorganic maximum they given structures from second inorganic and first inorganic compounds only. Out of NCERT book structures they want to give. That's why till second inorganic structures completed, HNO3, N2O, NO, all structures you have to learn, no problem. Next, another one important one, net formal charge or average formal charge. Average formal charge. Net formal charge or average formal charge. Formula: negative magnitude of negative charge by number of anions. Negative charge by number of anions. Negative charge by number of anions. For example, SO4 2 minus. This is right as a SO minus, O minus, double bond O, double bond O. Right. Here negative charge of 2 negative charge. That means minus 2 by or 2. Negative charge 2. Minus 2 by number of anions 4. 1 to oxygen anion 1, 2, 3, 4. 4 equal to minus 1 by 2 or 0.5. Positive also take. Sometimes exam negative sign given, sometimes not given. Just negative sign indicated gain of electron. So negative sign not represents the mathematical sign. This negative sign does not represent the mathematical symbol. Just represents the gain of electron. Minus 1 or sometimes exam plus 1 by 2 0.5 also correct only, or 1 by 2 also correct only. Okay. Next, like that another example, PO4 3 minus, PO4 3 minus, P double bond O, O minus, O minus, O minus. So net formal charge equal to negative charge. How much negative charge? 1, 2, 3. 3 by number of anions. 3 by number of anions. How many anions is there? 1, 2, 3, 4. Equal to So this is the net formal charge or average formal charge. They asking overall formal charge. SO4 2 minus, PO4 3 minus. Otherwise, another example. CO3 2 minus. CO3 2 minus. Okay. Now net formal charge means negative charge. How much negative charge? Minus 2 by total number of anions 3. Total number of anions 3. That means almost minus 0.66 like that. Okay. In exam, positive value given also correct only. Just negative sign indicated gain the electron or anion. In exam, if positive value given also correct. Positive value also correct. Okay, this is the net formal charge or average formal charge. Okay, students. Thank you. Thank you.